All right, so this is an example where we are going to actually be finding the resultant vector. So in this example, we are given two different vectors. So I'm going to actually draw them separately and find their components. So my first vector is going to be my airplane. So the airplane is traveling at 600 miles per hour, so that's the magnitude, with a bearing of north 35 degrees west. So that is 35 degrees, and then it had a magnitude of 600. Okay, so if I put that into component form, that's 600 times this angle is 125 degrees. Sine 125. Okay, so that is the component form of the airplane. And then if I want to do the same thing for the wind, so the wind is north 40 degrees east. So this is 40, and it has a magnitude of 60 miles per hour. So in this case, theta is 50 degrees. So my component form of the wind is 60 cos 50 sine 50 degrees. Okay, so we want to find the resultant speed and direction of the plane. I do always think that, that vector was actually really bad. It should be way shorter. Okay, so it really should be 1/10 of the length of the other one. But it's always good to sketch kind of what's actually happening just to make sure your final answer makes sense in context. So we had this vector, right? That was the airplane. And then we had a much shorter vector going off in this direction, right? I just took this and slid it up to the tip of the other vector, or the tail of the other vector. And then our resultant vector will be something like this. Okay, so like if we got components that were, I don't know, negative, like putting you down here, that just wouldn't make sense. So just make sure your answer does make sense in context and kind of keep your end goal in mind. But what we're going to do is we're just going to add the components together. And that's going to give us the component form of that resultant vector. And then we can answer questions pretty easily from there. So adding these two together, I add the horizontals and I add the verticals. So my resultant is 600 cosine of 125 plus 60 cosine of 50. And then my vertical is 600 sine of 125, 60 cosine 120, sine, Let me fix that. Plus 60 sine of 50. Okay? And then you just type these in your calculator. So you type them in separately. You type this in. That gives you your horizontal component, which in this case is negative 305.579. And keep in mind that this is talking about miles per hour. And then the vertical component, you type this in to your calculator and you would get 537.454. And again, also miles per hour. You don't actually have to write that in there. I just wanted to keep you in context. Okay, so this is this vector in component form, right? And that does make sense, right? We're in the second quadrant. We have a negative horizontal movement and a positive vertical movement. So that does make sense with kind of the scenario we're in. So the question asks us the resultant speed and direction of the plane. So to find the resultant speed, that just means magnitude, right? Speed is a magnitude. So to find the magnitude of this vector, it's just Pythagorean theorem, right? Because it's really this little right triangle that we're working with. Okay? So to find the magnitude, we are going to do, what do I want to call this? I'll call it R. I want to find the magnitude of r. I do the square root of the horizontal squared plus the vertical squared. So that gives me a magnitude of 618.252 miles per hour. Okay. And that hopefully makes sense, right? Because that's the hypotenuse of that triangle. And then to find the direction, I would say we're going to ask you for the direction in whatever kind of notation you get it in the question. So like in this question, we gave you bearings. So we're probably going to be asking you for a bearing in your final answer. So let's find the bearing of this. So let's kind of zoom in here and look. So again, we are talking about the right triangle, the yellow hypotenuse, and then we have the horizontal and the vertical components. All right, call it X and Y. Right. So in this triangle, we can use tangent to figure out what the reference angle is. And then we're talking about a bearing. So what I actually am going to end up caring about is in here, right? Because it's rotation from north or rotation from south. So I'm going to find theta first. And then I'm going to do 90 minus that to figure out this piece. And then we're going to have a bearing north something west. Because we're rotating west from that north axis. Okay, so we'll go down here and actually do that trig work. So to find theta, which in this case is a reference angle, it's not actually the bearing, I'm going to do tangent inverse of opposite over adjacent, or sine over cosine. Okay, and you actually don't need the negative in there, it's just giving you a reference angle. But it ends up giving you, this would give you negative 60.379 degrees, which is the reference angle. But remember, this is what's going on up above. This is my resultant vector. And I just figured out that this is 60.379. And I need to know this piece to be able to talk about the bearing. So I'm going to do 90 minus 60.379, and that's going to give me 29.621 degrees. So my bearing, so here's my magnitude, and my bearing to finish this question up is we are tilting west of north 29.621 degrees. So there's your bearing for this problem.